group of questions, we are looking at properties of exponents and roots. So in the first one, it says the cubed root of negative 27. A cubed root is asking what times itself 3 times gives us that number. So what would that be? Negative 3 times negative 3 times negative 3 would be negative 7. Second one has a fraction exponent. How do we rewrite a fraction exponent to evaluate it? Yep, the bottom is a root, so it gives us a square root, and the top is a power, so 36 to the first. What is the square root of 36 to the first? 6. No, the square root of 36 is 6. So that's asking what times itself is 36, and then to the first power, which doesn't change it. So 64 to the 2/3, when we rewrite that, what kind of root will it be? Cubed root of 64 squared. The bottom is the root, the top is the power. So cubed root of 64 squared. What times itself 3 times is 64? 4. And 4 squared is? 16. Number 4 is a negative exponent. What do negative exponents do? It's a fraction that goes to the bottom. So it's going to become 1 over 27 to the 1/3. And what does a 1/3 power become? A cubed root. So we get 1 over the cubed root of 27. The cubed root of 27 is 3. So we get 1 over 3, or a third. On number 5, we have a power outside of a group. What do we do with a power outside of a group? Kind of distribute, give it to everything inside. But they already have powers. So what do we do when we have a power to a power? Multiply them. So we get 4 to the 1/3 times 3. What's 1/3 times 3? 1. So 4 to the first. And 5 to the 1/3 times 3. So 5 to the first. Which is what? 20. On number 6, we begin bringing in some variables. So when we have multiple things in a root, we're going to deal with them individually. So first, the number. What is the cubed root of 64? 4. Then, who can tell me what we do when we have a power inside of a root? How do we simplify that? We think of grouping them up. What kind of arithmetic will we do to calculate it? It'll be division. Remember, when we have a fraction exponent, the top is the power, the bottom is the root. So we can divide the power by the root, kind of in a sense making that a fraction. So I get x, what? Squared, 6 divided by 3. Y to the first, so we don't really need to write that. Z to the third. We do the power divided by the root. Now all of these went in evenly, so that was nice. What if they didn't? Like, what if this was z to the 11th? 3 doesn't go into 11. Okay, so we take out as much as we can, so we still would have taken out the same amount, but we would have had a remainder of a couple leftovers inside. So if it doesn't go evenly in, we still take out as much as we can, thinking about how many times does it divide evenly, and then any remainders would have to stay under the root. Number 7, what do we do when we divide? What do we do with exponents? Subtract. So I get x to the, be careful, 7. 4 minus negative 3. So we're subtracting, but we have a double negative. Okay, 4 minus negative 3 gives 7. And y to the third. For number 8. It is not the square root of 87. Question.
What if it was like x to the 4th and y to the 5th and y over y to the 2nd? So they're like split. Oh, and x to the negative
If what was switched? Which
Okay.
ones do you want switched?
The variables on in the denominator,
Mhm.
if they were opposite, then do you still do the same thing even when they're not on top of each other?
If it, like if we had both x's on top and both y's on bottom?
No, like,
And if we had x or y minus 3.
yeah.
Oh yeah, if they're backwards, that's fine. So like if it was written in a different order, like this, is that what you mean? That's fine. We still do the same thing even though they're not directly on top of each other, because when we multiply, it doesn't matter what order they're in. 2 times 3 is the same as 3 times 2. So even if they're not written in the same order, we can still apply the same rule.
So what if x to the third, x to the negative third, and y to the negative second were on the top, and x to the fourth and y to the fifth? Would you bring them down and there just be a 1 above it?
If it was written upside down, we would do the same thing. We'll just subtract top exponent minus bottom exponent. That's always what we do. So what's on top and what's on bottom, just always do top minus bottom. You still do top minus bottom. So if there's a negative exponent on top, you would just do that minus whatever's on the bottom.
So like, if there were negative 4 on the top and negative 2 on the bottom, or if there were negative 4 on the top and just positive 2 on the bottom,
So then we do a negative 4 minus 2, get negative 6.
so x to the negative 6, but then wouldn't we like put it on the...
Yeah, negative exponent should be put on the bottom as a final answer. Yep. All right, for number 8, it is not the square root of 87. I promise you will have a question similar to this. The numbers will be different. And sadly, I promise somebody is going to put the equivalent of the square root of 87. It happens every year. I can warn, it's going to happen. Don't let it be you. Heed my warning. You cannot add roots that are different. Okay? You cannot add together roots that are different. We need to simplify them so that hopefully they will turn into the same kind of root, and then we can combine them. How do we simplify square roots?
By taking perfect squares that divide into the
Okay, so what's a perfect square that goes into 75? Okay, so we're going to change that into a 25 times 3. And what's a perfect square that goes into 12? 4 times 3. What is the square root of 25? What's the square root of 4? Now they are the same kind of roots because they are both square roots of 3. So if I have 5 of them plus 2 of them, I get 7 of them.
would you write like whatever 49 times 3 is, like the square root of 147?
No, leave it just like that. Don't unsimplify it. Okay. We want all answers completely simplified. So that is completely simplified. All right? Questions on any of these first 8? If you would like to practice more problems, these types of questions were found in 7.1 and 7.2.